Hi there, I'm Mike of Buffalo Metrology, and we're creating a video today to go over what is FreeScan and how is FreeScan applied to engineering groups. With us today is our scan unit, being our FreeScan Trak Nova, which is 2 units in one, being a dynamic tracking system. This is our UE Nova, being our tracker with our TE Nova here to be applied to our 3D scan that we're creating. So our tracking system is able to provide a wide range of wide viewed scans. And why is that important? Because let's say you're on a construction job or you're at a large hydroelectric turbine that you're measuring a large impeller. You need a large amount of space. We're able to provide our tracking system that allows scans to be done all in one file of one item. So for use case example today, we're going to go over this scan system with a lawnmower from our office and our tracker with our scanner. Let's first start with our tracker. So taking this, our T Nova, moving this out of the way. We have our UE Nova here, and this is our tracker. So what I'm going to start with is that I'm going to be able to identify our hexagon markers with our scale bar. So let's get started. So our scale bar has been identified by our FreeScan software, and we're going to make sure that we're able to get as many as the markers as we can for our tracker with on our software. 17, 18 markers picked up right now for tracking. For when we start our scan, make sure we get this into the green here, that's in green. And we're going to go ahead and optimize our markers, our global markers. Okay. And now since we have our markers identified, we can now move our tracker as we wish to for our scan. So let's now go to our handheld scanning, being our TE Nova. And I'm going to go to 1 mm for our scan mesh. And now I'm going to take our TE and do our scan. So here you can see our 7 laser lines have appeared, 7 laser lines. And we want to start with our 50 crossing laser lines. So we have 3 modes, being our 7 laser lines, our 1D pocket laser line scan, and our 50 laser lines that we're going to be covering first. Our 1 and 50. So right now our software should be picking up scan data since our laser lines have appeared in light here, which is good. So I should probably get the front muzzle of the leaf blower before I move to the back where our electric leaf blower is. And we want to get to the back of our electric leaf blower, right by our fan here, and make sure that our tracker is able to see our TE Nova. That's always how we're able to have wireless scan. So, and really, this might be a good time to move our tracker a little closer for we to be able to pick up within field of view. Now, once I'm ready to, and I feel like I've gotten enough of scan data in our FreeScan software, I then want to move on over to our 7 laser lines. Here, 7 laser lines, a little bit more detailed in our, if we go too far away, a little bit more detailed in our scan mesh. Well, more scan data will be picked up now with our 7 laser lines. All the scan data we might have missed. Now that scan data, once it's done, does get to convert into an STL model, the stereolithography model, and that 3D model could be used as a comparison to your ODM models from the manufacturer of what the initial item was supposed to be in comparison to our 3D scan. And that's why we want accurate scanning, as accurate as can be. That's why we go to our deep pocket scan when needed. Now, then with our deep pocket scanning, we're able to get as much of the detail as possible when doing our scan. Okay. Yeah. And then we should have a part. I could put on top there, top of the mold of our leaf blower, and we're on to stop right there. So take a look at our collected model of our scan done with our handheld scanner, with our tracker as well, doing our scan system with our model. And you might not be able to see much of my screen from there, but you can see that our leaf blower, most of the model has been picked up from scanning. So let's kind of get an overview of what is 3D scanning and how 3D scanning is done in relation to taking a part that's made and comparing it to an ODM model or a 3D model come from the original supplier or manufacturer. And with this scan data, we'd be able to compare any deviations from the scan to the initial model. Okay, thank you for checking our video, and thank you for stopping into our channel.